Welcome in. Happy Monday, everyone. We are going to be doing some rational functions. So if you know anybody struggling with this topic, share the live out with them. Welcome in. I know it's been a minute. I'm back. Alrighty, so let's simplify each expression. How we're going to do that is you got to know how to factor. So we're going to look at this x squared plus 9x plus 20. We're going to start with two parentheses. Since we have positive, we're going to put plus, plus. Then we ask ourselves, what times what gives us x squared? X. And then what times what gives us 20, but adds to 9? So we could say 4 times 5 gives us 20, and then 4 plus 5 gives us 9. And so that's how we factor. A trinomial. Then we can look at this bottom one. This is a binomial because it has two terms. And then we can ask ourselves, what can we factor out? Can you guys put it in the comments? What can we take out of, what's the GCF, greatest common factor? What do you guys say? Thank you for the double taps. Happy Monday, everyone. I hope everybody had a wonderful weekend. So what we can take out of here, what they both share is an 8. So we can take, good, Anna, yes, we could factor out an 8. And what that means is like we're going to divide this by 8 and divide this by 8. So 8 divided by 8 cancels and we're left with an x plus 16 divided by 8 is 2. And so that's factored there. Times. Okay, if we keep on the bottom, okay, this x squared minus 25, hopefully in your brain is screaming difference of squares. And with difference of squares, you're always going to have a plus and a minus. And then you say what times what gives you x squared, x and x. And what times itself gives you 25, 5 and 5, okay. Now, this one up here, we have a GCF. Does anybody know what the GCF is of this trinomial? What can we take out? Does anybody know? Thank you for the follows, you guys. Thank you for the double taps. 4. Good. Anna and Cornelius said 4. Perfect. So we're going to divide each of these by 4. And we get x squared. If we 16 divided by 4... gives us 4x, and then 16 divided by 4 is just 4, okay? Now we have this trinomial that we could factor some more, so we're going to put our 4 out. We're going to go straight to two parentheses. It's all plus and plus, and then we say what times itself gives you x squared? Well, x times x, and then what times what gives you 4? 2 times 2. And this is like probably the best part about it, right? You do all that hard work and then you get to cross simplify. So what we can do is we could take out this x plus 2 right there. We have this x plus 5 is out. And I think that is pretty much it, right? Oh, we got the 4 and the 8. That we can cross out. So this goes to a 1. 8 divided by 4 will make it go to a 2. I think that's it, you guys. So what we have left in our numerator is x plus 4, x plus 2, all over. And then our denominator, we have this 2 times x minus 5. And this is how we simplify the rational function. Any questions? Wait, why are we crossing them out? We're crossing them out because we're trying to simplify the expression. And so we're simplifying what they have in common. So we're crossing out because x plus 5 divided by x plus 5 goes to a 1. And x plus 2 divided by x plus 2 goes to a 1. So we're simplifying. We're taking out what they have in common. Great question. Oh, good, Mari. You're doing this in class right now? Beautiful. Oh, Jade, I'm sorry. So are you confused on the factoring part or the cross out part? Which part are you confused on? Oh, you just joined like 2 minutes ago? Okay, no worries. We're going to do this one. Okay, I'm doing that in class and it's kind of confusing, laughing out loud. Oh, no worries. Oh, good. I'm glad you guys are doing this in class right now. Factoring for me. Yeah. It is the factoring that's, yeah. See, you can't even begin to think about crossing out if you can't even get the factors, right? So that's the frustrating part. So let's just practice. That's how you get better. So let's look at this first one. Okay, first off, can we ever divide fractions? That's what you have to ask yourself. You have to go back to your middle school days and you have to say, can I divide fractions? No, remember we have to do keep, we have to change it, and we have to flip it. So this side will stay the same. So we can rewrite that. Plus 6a plus 3. And you know what? Do it step by step, you guys. So many of us try to do all of it at once. That's where we get confused. So we change this division to times. And then we have a squared minus 4. And then we could put our 12a squared minus 12, okay? Because we have to flip this. We have to do the reciprocal, all right? Now that we did that, now we can start tackling this, okay? Let's start with a difference of squares, okay? This is a difference of squares because this is a perfect square and this is a perfect square. Well, some people don't know what a perfect square means, right? What is a perfect square? Well, a perfect square is a number times itself. See, if you understand what perfect squares is, then you can start identifying whether it's a difference of squares. So difference of squares, you always have a plus and a minus. Always, okay? And then you ask yourself, what times what gives you a squared? Well, a times a. And then what times itself gives you 4? Good. Anna said a plus 2, a minus 2. Beautiful. Yes. Perfect. All right. Let's stick with this side before we go to the trinomial. So when we have something like this, we're saying, what do they have in common here? So what can we take out? What's the GCF? Does anybody know? 12. Yes. They both share a 12. Perfect. So we can, let's go over here first because this is going to be 2 steps. So if we take out a 12, that means we're dividing this by 12 and dividing this by 12. So we're left with an a squared, okay, minus 12 divided by 12 is just 1. Okay, now this is where it gets a little tricky, right? Because does anybody know what type of factoring this is right here? Does anybody, a squared minus 1? Does anybody see it? It's a difference of perfect squares. Yes, a difference of squares. Yes, it is. So since it's a difference of squares, we always do plus or minus. And then you ask yourself, what times what gives you a squared? Well, a times a. And then what times itself gives you 1? 1 times 1. Okay, so we're there for right now. Now let's get to the harder factoring, right? So we're going to do this one. We'll go up here, over here. So you always ask yourself, what can you factor out of this first? You always look for a GCF, okay? You always look for that. And if you're screaming in your head 3, beautiful. Yes, you guys, I saw those 3s coming in. 3, 3, 3. So we can factor out a 3 first. So that means I'm dividing this by 3, 3. So I'm left with a squared plus 6 divided by 3 is 2a. And 3 divided by 3 is 1. Okay. All right. So now we can do 3. And we're going to go straight to 2 parentheses. Okay. We have plus plus. So plus and plus. And then we ask ourselves, what times what gives us this a squared? A times a. And then what times what gives us 1? Well, 1 and 1. Now, some of you guys might be like, well, how are you getting the 2 though? Right? Some of you guys. Well, 1 times 1 gets us 1 and 1 plus 1 gets us 2. So that's how we know it checks. Okay? You add them and you have to multiply them. I'm here like I'm finally gonna understand algebra. You are! You are gonna understand it. It takes that one person. I'm telling you. This is the AC method, correct? I don't know what is AC method. I'm not sure. This is more like the guess and check method. Okay. All right. So let's do this bottom one. Okay. We go straight to 2 parentheses. Because we have no GCF to take out of, they have nothing in common. When you have minus, minus, you guys, when you have 2 minuses, the signs have to be plus and minus. That's a rule, okay? Thank you for the rose. Nay, thank you, thank you. So it's a plus and a minus, okay? And then you ask yourself, what times what gives you a squared? Well, a times a does. And then you have to say, what times what gives you 10? So let's figure out what times what gives us 10, right? So if we do that, we have 1 and 10, 2 and 5, okay? And then now we have to say, which pair can we add to give us a -3? Well, the only pair that can give me a -3 is a 2 and a 5. Now I have to say which one has to be the negative. Do you guys see it? Oh, good. Man said -5. Yes. So the 5 has to be negative because if you do 2 minus 5, that gets you that -3, which we needed in the middle. So this is our answer. So we put the +2 with the plus and the 5 that's negative with the minus. And now that we have factored everything out, we can start cross canceling, okay? So let's see, what do we have? We got this a plus 1 here. We got the a plus 2, so that's out. What else do we got? I think that's it, huh? Oh, don't forget the 3 and the 12, right? 3 goes into 3 one time, and 12 divided by 3 goes into 4. Good. Yep. A plus 2. Good. Yep. Saw that one. And I think that's it, you guys. So let's write up our numerator. So we have a plus 1. And we have an a minus 2 over an a minus 5. See how this 4 is right here? Always write it in the front, you guys. Okay, always put your coefficients in the front. Thank you, Dynasty, for the roses. Thank you, thank you. And then we have a minus 1 at the bottom. A minus 1. And then this is our beautiful answer, you guys. Okay. So multiplying and dividing rational functions, okay? Now what we're going to jump into next is we're going to jump into adding and subtracting, which is those are they're difficult, okay? They're difficult. So let's jump there. Oh, you're so welcome. So let's jump to this one, B, okay? And also, you guys, if you want to rewatch this, right? Go to I always post all my lives on my YouTube page at Impact Math 19 on my YouTube page. So follow me over there, and then I'll repost these lives. And if you want to try them again, that's where they'll be at. Okay. All right. Now you have to go back to your fraction rules, right? Because in order for us to subtract fractions, we always have to have the same denominator. And this is the part that's like, oh no, this is the part that killed us in middle school when we were trying to find common denominators, right? Now it just intensifies because it gets letters, right? But what do 9 and 6? What can they both go into? Does anybody know? Oh, you're so welcome, Anna. Yeah, good. Love said LCD. M. Jordan said 18. Yes. AJ said 54. You're not wrong, AJ, with the 54, but it'll just take you more. If you do that big number, you're going to have to simplify a lot towards the end, which is not wrong, but it's just going to take you more time. And so if you have a time test, that eats away at you, okay? So 18 is our least common denominator. So what we have to ask ourselves is, if I want this to be 18, okay, but remember we got these letters too, right? So the L, least common denominator, is 18 for the 9 and 6. And then remember, you need the letters. So it's Y, Z, okay? This is what we want at our bottom. Okay. So 18 YZ. I know I want that for here and for here. Now the question is, what do I have to multiply 9 by to get me 18? Good. Tanisha said 2 times it by 2. Good. So I'm multiplying this by 2. Perfect. And the 6 by 3. But hold up. Remember, I need it to be YZ also. So this is missing the Z part. And this one is missing the Y part. What we do to the bottom, we must always do to the top. So this has to be 3Y up here. And this has to be 2Z up here, okay? So now we can do 2 times 2 is 4XZ. Just put the letters together, okay? 7 times 3 is 21. And then Y times Y is Y squared. Okay. Arlena, happy Monday. So now we can do, right? This is our numerator. So now we can subtract them. We can do 4XZ minus 21Y squared over, remember our denominator stays the same, 18YZ. And this is our beautiful answer. Reese said, now I feel like I need to learn this. only if you need it. Only if you go into college, you got to pass that college algebra. Right? Oh, thank you, B. Okay. Chavez, I do 6th grade and up. And then like a lot of 5th grade material is in 6th grade, so it kind of blends. But I mostly do for on this page, 6th grade and up. Okay. Yeah. Okay. I just finished my exams on rational functions. Oh, I hope you did good on it. Are you guys going to radical functions now? Or what you guys doing? Are you guys doing logs? What you moving to after this? What do you guys move to? Yes, this is algebra 2. Oh, love, you took yours on Wednesday? Yep. Cake said I'm in algebra 2. This is like algebra 2 math or intermediate college, intermediate algebra in college. All right, so let's keep on going, okay? So first we need to find out what our denominators are, okay? What our denominators are. So we're going to factor this. Okay. So we have a plus and a minus. Whenever you have a plus and a minus, that's your sign, plus and minus. And then you say, what times what gives you x squared? Well, x times x. And then what times what gives us 15? Well, we would have 1 and 15 and 3 and 5, okay? Now we ask ourselves, which pair can add us to 2? Well, only 3 and 5 can add us to 2. But we need one to be a positive and one to be a negative. So our smaller number is going to have to be the negative, because if we do 5 minus 3, that's going to equal a positive 2, which we need in the middle. So the 5 is positive, the 3 is the negative. Okay, good. All right, let's factor this one out. What is our GCF? What can we factor out of this? What do they both share? Let me see it in the chat. Throw your answer in the chat. Love said 5. Cranberry said 5. Good. Yes, you guys. 5, 5, 5. Yes. So then we're going to divide this by 5 and divide this by 5. So if we divide this by 5, that leaves us with 1x minus, and if we divide this by 5, 15 divided by 5 is 3. All right. So now that we know what's in our denominators, right? Now we're able to find our least common denominator. So whenever you're trying to find the least common denominator, you take everything. So we have a 5. We have an x minus 3. And we have this x plus 5. This is what we need in both of our bottoms. Okay, this is what we need. This is what we need. So I'm going to write this here and here. So we need a 5, a x minus 3, and a x plus 5. Here we need the same thing. Okay, because we're subtracting fractions. Whenever you subtract fractions, you have to have the same denominator. So now we can go back up here and we can ask ourselves, this is where we ask ourselves, what is missing from this to here? Can you guys see it in the chat? What is missing from this to here? What do you guys say? What's missing? What don't we have? Thank you for the follows. Thank you for the shares. 5. Good. Yes, 5. Yes, there's 5 out here. So what I do to the bottom, if I multiply this by 5, I have to do to the top. Okay. Now let's go over here. What is this? What's missing from here to here? What are we missing on this side? Oh, good. You're taking college algebra? Yeah, you guys should be doing this in college algebra. X plus 5, good. So we put x plus 5 down here, but whatever we do to the bottom, we must do to the top. Okay, now, it's where it gets a little bit tricky, right? I'm trying to think, should we just rewrite it? Or should we multiply it out? Let's just rewrite it so people don't get confused. So we have a 5 up here, and we're timesing it by 2x plus 1. And then we have this 7, and we're multiplying it by x plus 5, okay? Whenever you have a number attached to a parenthesis, you have to distribute. What that means, we have to multiply. Okay. So 5 times 2x gives us 10x. And then 5 times 1 gives us a 5. Okay. Over our same denominator. Now, this is what I want to see in the comments. Okay. This is the part I want to see. Can you guys distribute this for me? Let me see what you guys get when you guys distribute this in the comments. Angel, good. I'm glad you're here. That's what we're doing is algebra 2 today. Okay, 7x plus 35. Ooh, 7x plus 35. 7x plus 15. 45, I'm seeing. 35. Okay. Now, technically, you guys are not wrong. Some of you guys is not wrong, okay? But we have this, remember, this is a -7 here. This is a -7. So if it's a -7, then really it's -7 times x, which is -7x, and then -7 times a +5, which is -35. Yes, somebody said, oops, I forgot the -7x. Yes, so some people were getting this part, which they saw -35, but they were making this positive. So remember, you have to distribute this minus sign with the 7. So this is the correct way, okay? Over the same denominator, 5x minus 3, x plus 5. Any questions just on this part? Juliana, don't say you cooked. You're not. Good. Mike said, okay, good. Now, like I said, some people just said it was 7x plus 35. You're not wrong if you said this, but when you go to subtract these, you got to remember that you're subtracting it from here and from here, which a lot of people forget that second part to distribute the negative and jacks them up. So I say, instead of trying to remember to subtract both places, just distribute it as a negative. And it'll save your mind from having to think. So now that we have the same denominator, we subtract our like terms. So we have a 10x and a -7x. And then we also have a +5 minus 35. So let's combine those. 10 minus 7 gives us 3x. 5 minus 35 gets us -30 over our common denominator, 5x minus 3, x plus 5. Now the question is, are we done? That's the question. Are we done? Yes or no? Let me see it in chat. Good. I'm seeing all those no's come in. Wonderful. The numerator is not simplified. Beautiful, you guys. So, what can we factor out of the numerator? A 3, 3, 3. Beautiful. Yes. So, if we factor out a 3, we're dividing this by 3. So 3 divided by 3 is 1, and that leaves an x. And then 30 divided by 3 is -10 over 5x minus 3, x plus 5. And now that is all we can do. That's it. So wonderful, you guys. Good. All right, let's go to the next. So we always want to start with our denominator, right? Because when we're subtracting fractions, we must have the same denominator. So let's start here. What can we factor out of 4x squared plus 4? What do they have in common? So basically, we're factoring two different equations. So basically, we are factoring two different equations. Yes. Yes. You're factoring the top and the bottom because this is a binomial and we already factored the bottom. So you're doing a whole bunch of factoring and then also remembering the rules of subtracting fractions. And somebody said, when do we get to the simpler stuff? I know. 4. Good. So we can factor out a 4. So if we factor out a 4, right? If we divide this by 4, we're left with x squared. And then 4 divided by 4 is 1. Okay. Now, can we factor this? Is that factorable? I do not know when I'm gonna be live next. I'm gonna try to go live every day until the end of this month. But I try and then my kids, but that's my goal. My goal is to go live every day till May 1st. Okay, no, yes, good. Okay. This is not a difference of squares. This is a sum of squares. And we can never, ever factor a sum of squares. So this is done. All right. Now here, this is a difference of squares. And so we can factor this. Okay. So what times difference of squares? Remember, you have a plus and a minus. And then what times what gives you x to the 4th? Well, x squared times x squared. And then what times what gives us 1? 1 times 1. All right. The question is, are we done here or can we factor more? That's the question. Is this done or can we factor some more? Factor more, Mac. Yes. Good. Okay. Factor more, Jay. Yes. Okay, good. Because here we have another difference of squares. That's what the crazy part about these difference of squares. It's like, man, when do they ever stop, right? Well, they stop when you have a plus sign in the middle. That's one way you know when to stop. But here we can go down further. So we have a plus and a minus. What times what gives us x squared? X times x. And what times what gives us 1? 1 times 1. And then we could drop down this x squared plus 1. All right. So now we have to come up with our LCD, okay? Our least common denominator. Remember, when you're trying to find that least common denominator, you need to take everything, okay? So we're going to take the 4 that we got here. We're going to take this x squared plus 1. And because they both got that, right? We got to take this too. X plus 1 and x minus 1. Okay. So this whole thing is going to be our least common denominator, okay? So I know I'm going to have that here minus here. Hi, baby. Good morning. Hi, Mia. Mm-hmm. You can. All right, so we're going to do 4x squared plus 1, and then x plus 1, and x minus 1. Okay, so let's put that here and here, okay? Because we know they both have to have it. So let's just put it. Now this is going to help us because it's going to help us see what we're missing from up here. So this one has the 4x squared plus 1. We're missing this whole part from here and here, right? So we're going to add Let's do it. We're going to add this part. X plus 1 and x minus 1. Okay? This is what's missing. But what we do to the bottom, we got to do to the top. So we could rewrite this as 3x times x plus 1, x minus 1. Let me slow down. Does anybody have any questions on this side? Just right here. No? Okay, good. Y'all following? Y'all getting it? Okay. Let's go over here. What's the only one? So what is missing from this right here that doesn't have it right here? Let me see in the chat. What's missing? 4. Love said 4. Good. Yes. So 4 is missing. So if we multiply 4 here, then we have to do it to the top. So we do 2x squared times 4. All right. Now, this is where it gets a little hectic, right? Because we have to multiply this all out, and we got to multiply this. Well, let's go back a step. Remember how we got this, how we multiplied this, how we factored this was from here, x squared minus 1, right? So this is a difference of squares. So we could do 3x times x squared minus 1, because this is a difference of squares. So we just multiply it back. Okay. Now, whenever you have this attached to a parenthesis, remember that's distributing. So 3x times x squared gives us 3x to the cube. 3x times a negative 1 gives us minus 3x. Can you guys multiply this for me? What do you guys get when you multiply this one? Oh, what you doing on IXL? I love IXL. Um, 8x squared. 8x squared. Good. Now, is it a positive 8x squared or is it a negative 8x squared? Good, Kay. Incorporate this sign with it. It'll save you a lot of headache, okay? So, negative 8x squared. Whew, right? It's like, whew. Whew, where are we, right? So this is a negative 8x squared. All right, now we're going to put this all over. Remember, whenever you're subtracting denominators, you just keep it the same. It's the same denominator. So we're going to take 1 for x squared plus 1, x plus 1, x minus 1. Okay. Now, the question is, am I done? Is my numerator simplified enough? Is it done? Oh, hi. Oh, no, Gerardo. How you doing, hun? I know, I miss you guys so much. I'm going to have to come visit you guys on the senior day. That's when I was planning on bringing up my kids and stuff. But I miss you guys so much at Brewster. I got to come say hi to everybody. Don't be failing Miss Sarah's class. You better be going to after school help. Take out X. Take out X. Beautiful. Yes. Okay, so we're going to take out an X. Perfect. So if we take out an X, or are you in the new teacher's class, not Miss Sarah's? Whose algebra class are you in? So X, good. So then we're going to do, so if I divide this by X, we have 3x squared. If I divide this by X, it's going to be minus 3 because the X is going to cancel. And then we have minus 8x. And I think that's it, y'all. That's all we can do. And then we keep the denominator, 4x squared plus 1, x plus 1, X minus 1. And that's it. Ma'am, I usually start my lives. I'm all over the place. I can't even tell you a time. I'm trying to get more organized in my life. But by this month, I'm gonna try to just go live this time every day. Cause that's when like my house is more quiet early in the morning. So this is the goal from like 8 to whenever my kids start waking up. 8. I'm in Central Time, by the way. And then sometimes I try to hit it at night. Like on Tuesdays, I try to hit it around 5, usually 5 p.m. Central Time. All right, good. Any questions on this one? I think that's all we can do. Okay, hopefully they get to get a little bit easier for us, you guys. Because those trinomials, whoo, right? When you have these trinomials, binomials, difference of squares twice, it's like, oh, man. But let's try this one. This one should be a little bit more easier, okay? So here we have a difference of squares, okay? So we're going to go straight to 2 parentheses. So we have W and W. And then remember, difference of squares has a plus and a minus always. And then what times itself gives you 9? What times itself gives you 9? 3 and 3. So our LCD is going to be W plus 3, because they both, you have to take everything. W plus 3 and a W minus 3. Okay. So let's automatically put that down here. W plus 3, W minus 3 for both. Okay. And that way we're able to see what we're missing. So can you guys tell me? Oh, good. So somebody said the answer is 3W plus 7. Ooh, you already did the problem. Okay, let's see if you're right. Can somebody tell me what's missing from here? What are we missing? So what do we have to multiply top and bottom by that we don't have here? Somebody put it in the chat. Oh, chickpeas, don't let this math stuff scare you. That's the perfect time. 23, perfect time. Your brain is more, your brain is more focused. You know exactly what you want to go for in college. And then they also have the math lab, great tutors. Don't let that fear stop you in your growth. Jackie said W plus 3. Good. Get after it, especially while you young. W plus 3, W plus 3. Perfect. So 3 times W plus 3 here. And then see here, this, we already have it, right? So we're not missing anything. So we could just put the 2. And then we're going to distribute. Distribute. That means we're going to multiply. So 3 times W gets us 3W. And 3 times 3 gets us plus 9. And then we could drop down this minus 2. And it's going to be all over one common denominator. So W plus 3 and W minus 3. Okay. Does anybody see the like terms that we can combine? Ooh, I think I see what the person was saying. 3W plus 7, huh? Wonderful. So we can do 3W. 9 minus 2 is plus 7. Don't forget that denominator part. W plus 3, W minus 3. And this is your beautiful answer. So wonderful. Whoever said that, 3W plus 7. Beautiful. Yes. What grade is this, Jordan? Jordan, this is Algebra 2. Algebra 2. So it's some people take it in 11th grade, some people take it in 10th grade. Depends what track you're on. Thank you, John Wood, for the rose. Thank you, thank you. All right, this one here is a little tricky, right? It's a little bit tricky. Does anybody know? Does anybody know what's one thing we have to do to come up with the common denominator? Right? Because this says k minus n and this is n minus k. They're not the same. You have a negative and positive letters? Yes. So if I want, instead of writing n minus k, and I want it to be k minus n, somebody said multiply by -1. Take out a negative. Yes. Yes, good, you guys. So if I want it to be k minus n, I'm going to pull out the negative here. So let me do a little side note, okay? Because some people need to actually see it. So if I pull out a -1 from here, right? So if I pull it out, well, let me see. How do I want to write this? N minus k. And let's say I divide this by -1, divide this by -1. See how this positive divided by a negative goes to a negative n, and a negative divided by a negative goes to a positive k. See how the k is positive, and see how the n is negative here? So what we could do is we can rewrite this as k minus n. We can only do this by pulling out the negative. So when we pull out this negative from here, it goes here. So we could do k. Hi, good morning, my love. Good morning, good morning. K minus n. And then we have a negative. And then we could do another negative that we pulled out, right? And it would be k over k minus n. Yeah. Mm-hmm. Yep.
But this guy, be quiet.
Okay. Go plug it up in the living room, okay?
Daddy's asleep.
Okay. Okay, but you still gotta plug it up because you said it died?
Yeah,
oh, yeah. Go ahead. Plug it up. Okay. So a negative and a negative, you guys, equal a positive. So we can rewrite this as k plus k. Remember, once you get the same denominator, it stays the same. K minus n. So can somebody tell me, what's k plus k? What does that give me? Put it in the chat. Why is there a double negative? There's a double negative because we pulled out the negative from down here. This is what we did on this side. We pulled out a negative by dividing by -1. To make this the same as this, to switch this instead of n minus k, to switch it to k minus n. So that -1 that I divided by, I had to put it out here. That's why it's the double negative. This negative, good question. This negative is from here. Yeah, this negative is from the one we pulled out. Good, 2k. Good, yes. So it's 2k over k minus n. Oh, it's not k squared because you can only get k squared when you're doing k times k. Because remember, when you do k times k, you add the exponent. So this would be 1 plus 1. And that's why it's k squared when you multiply. But when you add them, it's you're like, there's always an imaginary 1, so it's 1 plus 1. Okay. All right. Good. I hope that's making sense. Does that make sense? Okay. Wonderful. Okay. Any other questions before we go on to our next ones? Take a pick. Oh, actually, I will have this on my YouTube page, you guys. I always post all my lives on my YouTube page at Impact Math 19. So if you want to ever go back over our lives, try a couple of problems, pause the video, skip the video, go to my YouTube page. Okay, my YouTube. Why isn't it 3W plus 7 negative? Why isn't the 3W plus 7 negative? What do you mean? Why isn't it negative? See, it can't, because it's a positive 9 minus 2, so that's why it's a plus 7. And then this 3W, how we got this is we multiply by a positive 3. So that's why we did 3 times W, we got 3W, and then 3 times 9. And that's how we got the plus 9. And then we subtract the 2. So the only things that we can combine here is the 9 minus 2. And that's how come we got positive 7. The 3W was always positive. See, this one already had a W minus 3. What it was missing was the positive 3. Top and bottom. Thank you. Oh, you're so welcome. So you're basically doing 9 minus 2. Yes, because those are the only two like terms. We can't do this because it has a W attached. Great question. Okay. All right. Good. Okay, let's keep on going. Okay, so simplify each expression. All right, so they start to get a little bit more, right? Thank goodness we don't have no trinomials or no binomials, right? Monomials are a little bit better. So what's our LCD? What's our LCD? What's our LCD? If we want them to be the same. When are you going to do trinomials? Actually, I want to do rational functions, but I want to do solving them with the equal side. So that's going to be like my next lesson when I do algebra 2. Because, it's a little bit different when you have the equal sign and plus some. Okay, M2 squared. So it's going to be M squared P. Okay, mommy's almost done, okay? I got 2 more problems, okay? Okay. So, M squared plus P. That's our LCD, okay? So, we need M squared P here plus an M squared P. Okay, so now that we know that, we have M squared P. Nothing we can add, so we just drop down our 2. Here we're missing something. We have the P. We're missing the M squared. What we do to the bottom, we must also do to the top. So 5 times M squared is just going to be 5M squared. Remember, whenever you have the same denominator, you can add your numerators. But be careful. These are not like terms, right? So we just write it as 2 plus 5M squared over one of the denominators, M squared P. And that's our beautiful answer. How do you find the LCD? Sorry. Oh, so how you find the LCD is, it's called the least common denominator. And what you want is, you have to take everything. That's how I look at it. So what do I mean by that? See, this one had an M squared and P, and this one only had an P. So we had to take everything. So we needed to take the M squared, and we had to take one of the P's that they had in common. So let's look at this one. Let's practice with this one, right? Let's find the LCD. So for this one, we have a 4 They both have a 4 in common. So we know we're going to take a 4. It has a G. They don't have them in common, but we have to take a G because a G is there. And it has an H and an H squared. So we're going to take the most of the H's. So we're going to take a H squared. So that's our LCD. We have a 4, a G, and we take the most of the H's, H squared. Thanks for doing this. Oh, you're so welcome, sir. Good, Kaylin. I hope that makes a little more sense for finding the least common denominator. Okay. So now that we know this is our LCD, 4GH squared plus 4GH squared. So now we ask ourselves, what is this missing from this? We have a 4, we have a G, but we have 2 H's here, right? This only has 1. Thank you so much for the roses. Thank you. Star, thank you. I appreciate it. Shining Star. So can somebody tell me, what are we going to multiply by the bottom to make it look the same? Des said H. Beautiful. Yes. So we need an H. But what we do to the bottom, we have to do to the top. So that's why we say 7 times H, and we get 7H. Okay. Let's go over here. What is missing from here to here? What do we have to multiply by? Does anybody see it? G. Des said G. Raven said G. Beautiful. Yes. This is a G that's missing. So what we do to the bottom, we have to do to the top. So that's how we get 3G. Now that we have the same denominator, remember when you have the same denominator, you can add your numerators. Be careful. These are not like terms. So we just write them next to each other. 7H plus 3G over one of these, 4GH squared. And that is our beautiful work. Oh, this makes more sense. Good, Kay. Good. So after they have been simplified, can they be solved? So this is no, that's a great question. These can't be solved because they don't have an equal sign. See, if they had an equal sign, then we can solve for something. When they just have expressions, they can't be solved because there's no equal sign. So that was a great question, because so many students be like, want to set it equal to 0 and then solve for a letter, right? They want H equals something, but you can't do that if it doesn't give you no equal sign. Okay. Yep. Great question. All right, my beautiful people. Thank you so much for joining me this morning. You guys have an awesome rest of your Monday. Kill it in class. And I'll try to catch you guys tomorrow morning. Minnie, what's up? Simplifying and equating is different. Yes. Yep. Oh, thank you. All right. Bye, you guys. Have an awesome day.